Hey everyone, a very warm welcome back to the channel. And today we are back with another very amazing question from the chapter of trigonometry. The question is asking us to evaluate the value of sine alpha plus sine 2 alpha plus sine 4 alpha, where alpha is equal to 2 pi by 7. And second part of the question asks us to evaluate the value of sine pi by 7, sine 2 pi by 7, sine 3 pi by 7. The maximum time allotted for this question would be 12 minutes maximum, and ideally you should try to do it within 5 minutes. So you can pause the video, give the question a try, and then return back to have a look at the solution. So I hope you all have tried it out. Now let us discuss how to solve the given question. Now the answer first of all to this question would be uh, root 7 by 2 for the very first part. Second part answer would be root 7 by 8. Now the concepts and formulas used are very basic. Cos 2 theta, sine 2 theta, sine 3 theta, sine A plus sine B, 2 sine S, sine B. All these standard formulas we should be aware of and we should know what they are. We should also know that summation of cosine series, when the arguments inside them are in arithmetic progression, then what is the formula for that sum? So it is clearly written here. It is simply equal to this quantity. And in a polynomial, we should know what is sum of roots taken r at a time. Okay. Now, how to solve the very first part? Let's see. So what we are saying is we are calling the sum s as sine alpha plus sine 2 alpha plus sine 4 alpha. Then what we are doing is we are squaring both the sides. So s square comes out to be equal to lambda plus 2s2, where what is lambda? Lambda is simply sum of their squares. Okay, it is very simple. A plus b plus c whole square is equal to a square plus b square plus c square, which we are calling as lambda, and s2 is simply sum of them, or sum of these terms taken two at a time. Now we'll basically evaluate separately the value of lambda and s2. So in this case, I am multiplying both sides by 2. So 2 lambda will become summation of 2 sine square thetas. But 2 sine square theta, I'm writing it as 1 minus cos 2 theta. So basically that's how I have gotten 3 here, and minus sum of cos 2 alpha plus cos 4 alpha plus cos 8 alpha. That's how we have been able to write it. But of course we can note that 8 alpha plus 6 alpha would be 14 alpha, but 14 alpha would be 4 pi because alpha is given to be 2 pi by 7. So that's why cos 8 alpha can also be written as cos 6 alpha, because their sum is an integral multiple of 2 pi. So what we are able to say is that 2 pi, now this entire thing I am transposing it to the other side, to the LHS. So plus cos 2 alpha plus cos 4 alpha plus cos 6 alpha is equal to 3. Now, of course, all these arguments are in arithmetic progression. So we can apply the formula that we had just seen. So on applying that and simplifying, we are able to obtain that 2 lambda plus this quantity is equal to 3. Now, the thing is that 4 alpha plus 3 alpha is equal to 2 pi. So their cosines once again would be equal because this is an integral multiple of 2 pi. Look, the thing is that cos of 2 pi minus x is obviously equal to, or in fact 2n pi also we can say, minus x is equal to cos x. As simple as that, nothing difficult here. So that's what we are using. So cosine of 4 alpha would be equal to cos of 3 alpha. Moreover, alpha plus 6 alpha is equal to 2 alpha. So sine alpha would be equal to negative sine 6 alpha. That is also very obvious because sine of 2n pi minus x would be minus sine x. So basically what I'm able to do is I'm able to write this as 2 sine 3 alpha cos 3 alpha, because I can express this angle as twice of 3 alpha, and then I'm using the expansion formula of sine 2 theta, and that's the reason why I've been able to write it in this form. And of course this entire thing is indeed equal to sine alpha. So what I'm doing now is I'm simply substituting in these values. So 2 lambda is as it is, 3 is as it is, but what I'm writing as sine alpha is like this: minus 2 sine 3 alpha cos 3 alpha, and in the numerator we already have sine 3 alpha, and cos 4 alpha I'm able to write as cos 3 alpha. So cancel, 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 cancel. So minus half is what it remains. So lambda comes out to be 7 by 4. So lambda we have found out. Now what about 2s2? So 2s2, now look, the thing is S2 was equal to this quantity. So I once again multiplied both sides by 2, and then I'm applying the formula of 2 sine A sine B, which is actually equal to how much? Cos of A minus B minus cos of A plus B. So that is exactly what we are applying, so that we have been able to write it as cos of, now what is A minus B? Of course, here it would be alpha, and what is their sum? It would be 3 alpha. So that's what we have done. Then on the next set also we have applied in the same manner, and on this set as well. Of course, alpha plus 6 alpha is equal to 2 alpha plus 5 alpha is equal to 2 pi, so their cosines would be equal. So basically we can say that cos alpha and this cos 6 alpha get cancelled, this and this anyway get cancelled, and these are equal, so once again they are getting cancelled. So of course we are left with the S2 is equal to 0. So S square is nothing but 7 by 4, and S finally comes out to be root 7 by 2. The reason it is a positive quantity is because of course it is going to be positive due to the reason that sine alpha is greater than 0. Look, the thing is S is simply equal to sine alpha plus sine 2 alpha plus sine 4 alpha, right? So sine alpha is already positive because 2 pi by 7 is an acute angle, and this particular sum, I can, the sum of the remaining two terms, we are able to write it as 2 sine A plus B by 2 cos A minus B by 2 using that formula. Now this thing is actually less than pi. It is not more than pi. It is between 0 and pi. So sine will be positive, and cosine of course is going to be positive of the acute angle. So since this is positive, this sum is positive, everything is positive, so indeed S is also going to be positive. Now let us discuss the second part of the question. So there are two methods. The very first method is using direct result from complex numbers, which is this one. So if you just put n equal to 3, you will indeed find that the LHS becomes the required product, and we actually get the value of the product of the actual product from this RHS as root 7 by 8. This result we had also seen earlier in the previous question, in the question number 17, whereby I had told you that this actually requires complex numbers to prove, and if you remember this result, it can be directly solved. Now what is another way in case you don't remember? Then we have a formal proof for this particular case. So theta 1, theta 2, theta 3, we are calling pi by 7, 2 pi by 7, 3 pi by 7. They clearly satisfy theta is equal to in an integral multiple of pi by 7 for some integer n. Okay, so what we can now write it as is 7 theta equal to n pi, or 4 theta is equal to n pi minus 3 theta. Taking sine both sides and squaring, of course everything will become positive, and we don't have to worry about this thing, and it will simply give us sine square 4 theta is equal to sine square 3 theta. And now of course I'm expanding it using, I'm basically going to write it as twice of 2 theta, so sine 2x formula I'm going to apply. So 2 sine x cos x whole square, and of course this is what we get on the LHS. Here we are simply applying 3 sine minus 4s cube whole square due to the square. So sine 3 theta formula expansion we have used, and then what I'm going to do, sine 2 theta expansion I'm going to use, and cos 2 theta expansion I'm going to use, and sine square theta I've simply taken out common from here. And then of course sine theta is not equal to 0 because none of them is an integral multiple of pi, so sine theta can't be 0 for any of these thetas. So sine square theta can be cancelled from both the sides, so we are basically going to be left with 4 4s are 16, cos square theta I've written as 1 minus sine square theta, remaining things also as it is, and the remaining things no change. Okay, now what we are going to do is we are going to substitute in this particular equation t is equal to sine square theta, and on simplifying it further, this is what we are going to get. Now of course this particular equation is going to have roots sine square theta 1, sine square theta 2, sine square theta 3, which we can call as t1, t2 and t3. So what we basically would now like to find is to find the product of roots. So we are just going to need the coefficient of t cube and the constant term, which we can easily find. The reason we can easily do that is only this will generate t cube, right? The highest power of this particular polynomial equation, which would be 3, will only be generated from the multiplication of these two quantities, which is minus 4. But actually when you take it on the other side, you will be able to see what we actually get. Now actually the thing is the coefficient of t cube, as we have said, is 64. Why is it 64? Don't forget the 16 outside. Indeed, it was -1 into 4, which was -4, but when it gets multiplied by 16 and gets transposed to the right hand side, it actually becomes 64. And what about the constant term? So basically, constant term here is 9. The constant term here would be 16 into 1 into 1, which is 16. When it is transposed to the other side, it becomes 9 minus 16, which is -7. Now the product T1, T2, T3 would obviously be sum of roots taken 3 at a time, which is minus of -7 upon 64. These are standard formulas which are also taught to us in polynomials chapter class 10th. And what is the actual value of T1, T2, T3? They are sine square theta 1, sine square theta 2, sine square theta 3, which we have substituted. And of course, when we take the under root both sides, we are going to get the value of this product as under root 7 by 8. Now, one thing to note is this is obviously going to be positive. That's why we are taking only the positive square root. So I am hopeful that you all liked the video and were able to learn something new. Make sure you like the video and comment down below what more chapters you would like to see. Subscribe to the channel and hit the bell icon to never miss an update. And I'll see you all in the next one.